In this video, we will be going over stoichiometry problems that ask us to solve for excess reactants. So in this problem, the question asks, how much excess reactant is left over when 17 grams of potassium hydroxide reacts with 20 grams of iron nitrate? The first thing we're going to do is write out the balanced equation. So we're going to have potassium hydroxide react with iron 3 nitrate. And here we need to predict our products. Now I notice that both of my reactants are formed by an ion bonding with a polyatomic ion. So we're going to predict that this is going to be a double displacement reaction. In other words, the ions are going to swap partners. So now the potassium will bond with the nitrate, and the iron will bond with the hydroxide. Now, since this is iron plus 3, we need 3 hydroxides to balance it out. And then we will balance our equation by putting a 3 by the KOH and a 3 by the KNO3. Now, to solve this problem, what we're going to do is we're going to take each of our reactants, which is going to be potassium hydroxide and iron nitrate, and we're going to do 2 sets of stoichiometry calculations, and we're going to pick a product to figure out the theoretical yield. So in this case, what I'm going to do is, you can pick either one, but for this example, I'm going to pick KNO3. Okay, so I'm going to take each of my reactants and see how much KNO3 will be produced in theory. So I'm going to start off by figuring out the yield for my KOH. Okay. So my KOH, potassium hydroxide, I start with 17 grams of KOH. Now what I'm going to do is, using stoichiometry, convert that grams of KOH into moles of KNO3. So my step-by-step process here is, first I'm going to convert my grams of KOH into moles. Then I'm going to use my molar coefficients here to figure out the moles of KNO3. Okay. So the first thing I'm going to do is convert KOH into grams, or excuse me, into moles. So I want my grams to be down here and my moles to be on top. So use your periodic table to figure out the molar mass of KOH, which gives you 56.1056 grams. Okay. And then the next step is to use the molar coefficients to convert this into moles of KNO3. So for every 3 moles of KOH, I will produce 3 moles of KNO3. Again, these numbers 3 come from here and here. Okay. Now, double check here that your units cancel out. So first, your grams of KOH cancel out here. And then your moles of KOH cross out there. So you are left with just the units of moles of KNO3. So you're going to compute this using your calculator to give you 0.303 moles of KNO3. Okay. Now we're going to repeat this process using iron nitrate instead. So we have 20.0 grams of iron 3 nitrate. And like we did earlier, we're going to convert this into moles first. So we're going to divide by the molar mass, which is 241.86 grams. And then we want to convert this into moles of KNO3. So again, we'll use the molar coefficients that we see by our balanced equation. So in this case, for every 1 mole of FeNO3, we have 3 moles of KNO3. Okay. Now double check again here if your units cancel out. So your units of grams cancel out here, and their units of moles, FeNO3 cancel out there. So use your calculator to compute, and you will get 0.248 moles of KNO3. So what we have here now is 2 different answers for the moles of KNO3. Now, the answer that is going to be the correct answer, or the actual theoretical yield, is going to be this lower number. This means that our limiting reagent is iron nitrate. Okay, so let me just explain this really quickly. Okay, the lower number must be the one that's the limiting reagent, because iron nitrate here can only produce 0.248 moles total. Okay, we can't produce 0.303 because we don't have enough iron nitrate. So this iron nitrate here is our limiting reagent. And in other words, our KOH, potassium hydroxide, is our excess reagent. So now we need to do is we need to figure out how much excess reagent is left over. That excess reagent is going to be our KOH, potassium hydroxide. So to figure out how much KOH is left over, what we're going to do is we're going to take these two numbers and subtract it by each other. So we're going to take 0.303 moles of KNO3, and then we're going to subtract that by 0.248 moles of KNO3, which leaves us with 0.055 moles of KNO3. What this answer means is that if we had more FeNO3, we could have produced an extra 0.055 moles of KNO3. So what we're going to do now is we're going to take this number here, moles of KNO3, and we're going to go backwards and calculate how many grams of KOH this equates to. So what we're going to do now is we'll take this value, 0.055 moles of KNO3, and then convert this into moles of KOH. So for every 3 moles of KNO3, we have 3 moles of KOH. And then we're going to multiply that by the molar mass of KOH, which is 56.1056 grams per 1 mole. Double check here again that your units cancel out. And you are left with your final answer of 3.09 grams of KOH. So this final answer is telling you how much KOH is left over after the reaction ends.